In this section, we're going to look at a new form of data called a table. And once we look at how tables work, then we're going to play around with code that manipulates tables. So it's very similar to the way earlier we did images and then looked at the code that manipulates images. The code to work with tables will actually, in some ways, look similar to the code that worked on images. So my goal is that the real patterns that make any sort of code work are going to start coming through. So tables are a really common way to organize data on the computer. So as a running example for this section, I'm going to use the Social Security baby names database. So the Social Security Administration does retirement benefits and stuff in the US, but they also happen to track every year what names are given to babies born in that year in the US. And so that's going to be kind of a fun data set that we're going to use. So here I've structured this as an example of a table. So as I was saying, table is a way of storing data. It's basically, you can think of it as like a rectangle. So the way the table works is that it is first organized into fields. So the baby data is organized into 4 fields, and the fields are name, rank, gender, and year. You can think of the fields as basically the columns that make this thing up. And then the data is stored in what we'll call rows. So here's the first row, it has the data for the name Jacob. So it says the name is Jacob, the rank is 1 for that name. And what rank 1 means for this data set is that Jacob is the most popular boy name for babies born in 2010. Then we have gender as boy and year is 2010. So the second row has another name. So each name has its own row. So in this case it says the name is Isabella, the rank is 1. So what that means is that Isabella was the most popular girl name for babies born in 2010. So then we see Ethan has rank 2 for boy names, Sophia has rank 2 for girls, and so on. The table just has all the names. In this case, they're shown sorted by rank. So there's 1 row per name. In this case, it has the 1,000 top boy names and the 1,000 top girl names. So there's 2,000 rows overall. So as I was saying, tables are really common for storing all sorts of data on the computer. You may have heard the term database. So a database is a related concept to this sort of simple basic idea of a table. Generally, the way this works is that the fields are, or you could think of them as the categories, the number of fields is not very big. Fields, there might be 8 or 10 or something. So they represent kind of the fixed categories we want to keep track of. And then the number of rows could be enormous. It might be millions or maybe even billions of rows. So I'll just mention a couple examples. So you could think of your email inbox is maybe stored in a table on the computer. So the way that would work is, well, what would the fields be? The fields might be something like from and to and date and subject and a few other things that you store per message. And then 1 row is just 1 message. So each message gets its own row, and then we have these fixed number of fields. So then when you go to your inbox, well, there might be 10,000 rows in there for all your email, and maybe when you go to your inbox, it just selects the 10 most recent ones and shows you maybe not all the fields, but maybe the most important fields from that message. Another example is Craigslist, or any sort of online auction site, where maybe it's stored. It could be stored in a table where 1 row is going to be 1 item for sale, and then the fields would again be sort of the categories that you want for 1 item. So the fields might be the price, the date it was listed, maybe a short description and a long description, and a few things like that. So those are just a couple examples of how many of the things you deal with day to day, often back on the computer, that's going to be stored in some kind of table. All right, so to make this real, I want to look at code to manipulate tables. And I'm going to use the baby name table as sort of our working example for a couple of sections here. So in this case, the baby data for 2010 is stored in baby-2010.csv. I should just mention, CSV stands for comma separated values. It's a standard for storing essentially table data in a text file. And it's a really simple, fairly old standard. So it's a pretty easy way to interchange data from one program to another. So in terms of the code, I'll make my analogy to images. So for images, we had 4 pixel colon image, and that would loop through all the pixels in the image, and for each pixel, it would run whatever this code was inside the curly braces. So for the table, it's going to be very similar. We're going to have 4 row colon table. And what that's going to do is it's going to loop through each row through the table. So it just starts at the top, it goes through each one. And for each row, it's going to run whatever code I put inside the curly braces. So here as a first example, that is the line very similar to loading an image. So that's the line that grabs the table and stores it in a variable, which I will inevitably just call it table. And then here I have the for loop, sort of looping through all the rows. And in this case, the simplest thing I'm going to do is I'm just going to say print row. So I'm just going to essentially just look at it, print each row in the table. So this is the baby data. So if I run this, there is row 1 and row 2 and so on. And it just, so you can see Jacob, Isabel, Ethan. These are fairly popular names. And then it's actually made my web page quite tall because, of course, there's 2,000 of these things. So there's Courtney with a K, the 637th popular girl name. And so it runs all the way down here, as I was saying, oops, to through 1,000. So Crew and Dania. So that is one thing. So I guess what this shows, sort of a bulk output thing, but what it shows is that line ran 2,000 times, once for each row in the table. So just as with the image, the for loop just went through and looked at each one. All right, so here I'm going to comment this out and run again just to get rid of the output so I can have my web page not be a mile high here. So what do we want to do with the table? Just looping through and printing each row, that's like, like for Craigslist or for your email. That's never what you want. What we want is to loop through all the rows and just pick out the 6 or 2 of the 2,000 that we want. So this is a very common thing to do with tables. It's sometimes called, in database terminology, this is called a query that I'm going to sort of narrow down to just the rows I want. So let's talk about the code to do that. So for our purposes, we're going to do this with an if statement. Put an if statement inside the loop, and then in the if test, we'll write a test to select just some of the rows. So here's going to be my first example. So here is the for loop. So that's looping through all the rows. And then inside the for loop, I've got this if statement. So what's going to happen is this highlighted code is going to run again and again and again, once for each row in the thing. And so what I've done is I've written a test here. And the goal here is, in this case, is to just pick out the rows where the rank is 6. And so let me talk about how that works. So what's going to happen is that highlighted test, that test is going to be evaluated once for every row. So in a sense, 2,000 times. So what I'm going to do is structure the test so that it's true for a row I care about. And then inside of here, I'll put a print. So it'll print the ones I care about. And all the other rows, this will be false. And so it won't print those. All right, so how does this work? So just as for the pixel, we had get red and get green and get blue, the row has get field. And so you can recall the row goes all the way across. It has a bunch of different fields. So you can say, well, which field do you want? The way this works is each field has a name. In this case, the names are name, rank, gender, and year. So in this case, I say get field, and then within the parentheses, I say in a string, which field do I want by name? So in this case, I'm like, oh, right, I want to go to the row and I want to pick out the rank. So this highlighted part, that goes to the row and that picks out the rank. Just as before, we would have a pixel.getRed, and that would pull the red just out of the pixel. So this is analogous, but for a table. So now my goal, for this example, is I want to just show the rows where the rank is 6. So this would require a new little bit of code. So having picked the rank out here, then it says equals equals, which I don't think we've ever used before. But 2 equal signs next to each other, that compares 2 things for equality. It tests if they're the same. And so row get field rank equal 6, what that says is get the rank out and test if it's 6. And if it's 6, we'll say that the test is true, and if it's not, we'll say it's false. So let me just try running this. So if I run it, what's happened is it went through all 2,000 rows, and for these 2 rows, that test was true, because that's the case where the rank was 6. And obviously, I could say like 127 here or whatever, and then we would get the 2 rows. It just happens each rank number has 1 boy name and 1 girl name in this data set. So that's why I keep getting 2 rows here. All right, so let me try another example. Also I should mention a warning about this. So I'll change this back to 6 real quick. So this use of the two equals for equality is a little odd in computer code. I think it would be very reasonable to think, oh, shouldn't it just be one equal sign, right, if rank equals 6? And unfortunately, the single equal sign in JavaScript already has been used for variable assignment. It's kind of already dedicated to meaning that. And so they couldn't use it for equality, so that's why there's this different symbol for equality. Now, just for this class, so it's actually a pretty common error coding to sort of accidentally type a single equal sign when someone meant two equal signs for comparison. In this case, I've outfitted the run button with some special checking code where it notices if in an if test it sees a single equal sign, and it gives this error message that basically says, hey, did you maybe mean to use two equal signs? So that is an easy error to make, but the run button will catch it for you. That's something I just did for this class. All right, so now let me do another example. So the test I did before tested if rank was 6, but really any kind of test, as we were doing before with images, will work here. So in this case, what I'm doing is I want to go through the data set and I want to find the data, let's just say, for Alice. So as I mentioned before, for get field, you can just pass in the name of any field. So you need to know what the field names are. For this data set, they're name, rank, gender, and year. So here I will go to the row and I'll say, hey, give me the name field. So I'll say name there. And then I'll equals test if the name is the same as Alice. So if I run that, in effect what this does is it pulls out the Alice row. It goes through all the rows, does this test, and if the name is Alice, that's sort of the English translation of this, then it prints the row out. All right, so that's the basic pattern. So let me just work a few examples for this. So the pattern is going to be, just as I was doing, we have a for loop, there's an if statement inside of it, and then really all of the action is in the parentheses of the test, where I say row.getField something, and I have some test about it. So let's try these. So if I run it this way, we pull out, it says if name is equal to Alice, I get the Alice row. If I wanted to look for something else, pull out some other data, we could say Robert. So Alice is 172. Robert is 54. I'll try Abby, 284. So what's happening is this highlighted test is happening all 2,000 times. And it's just a question of which rows are we picking out there. I did Robert before. I'll show you something kind of funny. If you do Bob and you run, nothing appears here. What's going on there is actually no one named their kid Bob, apparently. So what's happening is we're getting zero printing is happening here. This thing was just never true. That's sort of the pattern on the form, I guess, for just how people name babies, is that they tend, on the form, they put a long name, like Robert. So and then Bob is like they don't put on the form. Maybe that's just what they actually call the kid. All right, so let me try a different test. Let's say I want to test if the rank is 1. So I would change get field, and I would type rank here. And then the equals, I can say 1, sure. So that gives me the 2 rows, Jacob and Isabella, we saw before, those are rank 1. So, all right, what was the other one we did? 1,000. I say rank equals 1,000, then we get Crew and Dania. So the test we did earlier with images, like less than or equal to, all that stuff works too. So let's say I want to look at if the rank is less than 10. I can just say less than 10. And when I run that, you can see I get rank 1, rank 2, rank 3, right? All these are rank numbers where the less than 10 test is true. Although you'll notice the last I get is Aiden and Chloe, number 9. The rows where rank is 10, I don't get. And that's because this form of less than is a strict less than. So it's true for 9, but it's not true for 10. If you want, there's another form of less than where you're like, well, you want to say less than or equal to. And I don't think we did this for the images, but it's just, what you do is if you put an equal sign right after it, that means less than or equal to. So if I run it now, then it goes through 10. And that works for greater than as well. All right, so let's try greater than 1. So I could say I would like to see all the rows where the rank is greater than 990, let's say. And so I get 991, 92, up through 1,000. Okay, let me just try one more. So thus far I've just done examples with name and rank, and so inevitably I'm calling row.getField and just changing what string is there to pull out a different field. I'll try pulling out the gender field. In this case, the way the data is coded, the gender field is it's just string. So it's either the string boy or the string girl. So if I were to say if gender is equal to girl, hit run, then I get Isabella, Sophia. I mean, if you look at where it says girl here, what's happened is I've just gotten all 1,000 girl rows and none of the 1,000 boy rows. Oops. Alrighty. So let me get this back. So this is just a trick where I comment out print, so it prints nothing, and run it again. So then that way it just blanks out the output here. So just to repeat what the pattern is. So these first few lines were always the same, and I guess I was always printing the row. So that was always the same. What I change is the if test, and the gist of it, the pattern tended to be I would say row.getField, whatever field I care about. And then I would write equals equals or less than or equal to or something, let's say on the rank or equal to the name, to, in a sense, pull out the rows. And the rule was I'm pulling out a row if this test is true. And so with that in mind, well, whatever. This can be a good source of some exercises.